Ngare, mo discuss ko about what is tree search, types of tree search, and ilahang terminologies for para ato siya ma-understand. So, what is tree search? Tree search in computer science, a tree is a widely used in data structure that represents a hierarchical structure. It consists of nodes connected by edges, where each node can have 0 or more child nodes. So karon, in this part, maybe some maglibog pa ang sa nodes. So later on, ato it discuss unsa ni nga mga terms. So, where each node can have 0 or more child nodes. Trees are essential for organizing and representing hierarchical relationship between objects or data. So here, we're going to cover the definition of trees, fundamental terminologies associated with trees, and different types of trees. Trees traverse algorithms and various tree representation techniques. So, karon ang examples will be provided in C programming language, and they will be beginner friendly and easy to understand. So the definition of tree. So a tree is a collection of nodes that are connected by edges. It is a nonlinear data structure with a hierarchical organization. The nodes in a tree are arranged in a parent-child relationship, where each node can have 0 or more child nodes. The topmost node in a tree is called the root node, and it is the starting point for accessing the entire tree. So later on, magkita ko ninyo og picture where ato makita kung unsa si root, unsa si node, unsa si parent, unsa si child. So ali naatay code here. This represent the node in a tree. So nagamit ta og type def struct kay aron ato na siya tawgon dili na lang nato siya i-struct balik. So type def struct where na name nato is node na ay int data struct node pointer children max children. So kani siya muni ang array of child node where naatay integer nga data. So ang data magkuha og data, ang data nga variable magkuha og data, then kadto nga data i-store nato sa node, then iya i-store array sa array. So terminologies. To understand trees better, let's cover some important terminology. So node, each element in a tree is called a node. So not a picture here. So naay tree data structure, kana muna siya ang node. Kani sila kani circle. So differ sa kani inyong nakita, naasad na siya ay different names. Sa ato kasi kung edge. So edge is a representation, a connection between two nodes. It defines the relation between a parent node and a child node. So ang edge is this, kani nag-connect nila. Kana ni mo sabtan if ang node is parent ba or ang node is child ba or ang duha ka node is siblings ba. So root node, our root is the topmost node in a tree is called the root node. It serves as the starting point for accessing the entire tree. So this is the root node, ang pinaka first jud nga node. Kana. Muna siya ang root node. Then parent is a parent node that has one or more children nodes, and it is located above its child nodes and in the hierarchy. So this one muna siyang node, parent, kana. Then below that is the child node, kana, yun ang anak. Panipod, pwede sa siya parent node, kana, ngayon child, pwede sa siya. So a child node is the node that has a parent node. It is located below its parent node in the hierarchy. So muta kung ginan niyo ha. Then nodes that share the same parent are called siblings. They are the same level in the tree. So we have level here, level 1, 2, 3, 4. So kadto siya sa level 1 na atay parent. Then sa level 2, we have the children. Muna siya, child node. Then, after that, if ang usa daw kuno ka, if ang duha daw kuno ka child node, nag-share og usa ka parent, meaning siblings sila. So, this one siblings, this one siblings, siblings. So, leaf node is a node that does not have any child node. It is also as a terminal known as a terminal node. So, ang leaf node is wala na child, meaning this one. So, ang pinaka-end muna siya ang leaf node. Then, internal nodes are nodes that have one or more children nodes. They are neither leaf nodes or the root node. So, internal nodes should be somewhere here, but we don't have one. So, if nanay kaning ana, mo ba ganing ma-internal nodes kani? So, the height of a tree is the length of the longest path from the root node to a leaf node. It represents the depth of the tree. So, ang height, makita na nato siya is from here to the leaf node. So, kung taas pa ni siya muna, ang height niya. So, there, represent. You have level 4 node. Depth of a node is the length of the path from the node to the particular node. So, if you look at this one. Then we have types of trees. We have binary trees, balance trees, binary search tree. Then kanang binary search tree na ay AVL trees, red block trees, and B trees and Trie. So after this, we're going to discuss it one by one. So binary tree. Binary tree is a type of tree where each node has at most two children. So a left child and a right child. The left child is typically smaller than the parent node, and the right child is larger. However, this ordering is not strictly required. Binary trees are widely used in various algorithms and data structures. So here we have a code here that represents a binary tree node, and here is the linked list node, representation of node, a binary tree. So here, type depth struct binary node, which ang struct name natin is binary node. May type depth ta, so pwede natin na lang siya tawagon, hindi na natin siya balik-balikan ang code. So, inside sa kanang type depth struct natin, natay int data, struct binary node, pointer left, and struct binary node, pointer right. So, kaning data, then iyan na store, then iyan na ihatag ari sa left and right. So, na naman na the left child is typically smaller than the parent node, and the right child is larger. So, meaning, for example, here we have 40, so left child is typically smaller, so we have 20 here, then 60 here. Next is balanced tree. Balanced trees are trees that maintain a balanced structure, ensuring that the height of the tree is minimized. They provide efficient search, insert, and deletion operation. Example balanced trees include AVL trees, red block trees, and B trees. So nga rin, kanida ko no is iya daw i-balance ang ato ang tree. So for example, ari 0, 1, then 0, 1, 1, then 2. Then after that, if na nasa lain, iya na sa i-balance ang ari, ngara-ngara. Kailangan iya i-balance. Here natin not balance. So 0, 1, 2, di na pwede. 0, 1, 2, then 1, 2, dili pwede. Kailangan ana ni ana kani ana sa dili mo siya balance. Balance tree mo siya. So, binary search tree. Binary search tree is a binary tree that follows a specific ordering properties for any node in the tree. The value of nodes in its left subtree are smaller, and values of nodes in the right subtree are larger. This property enables efficient searching, insertion, and deletion operation. So, pareha na siya og code ni binary tree. Same na sila. Na ay int data, struct, nga ang kuha sa left, nga kuha sa right. So, yeah. Then, we have AVL tree. AVL trees are types of balanced binary search tree. They ensure that the height The left and right subtree of any node differ by at most 1. So this self-balancing property guarantees efficient operation in logarithmic time. Kaning AVL tree prevents this by ensuring the tree stays roughly balanced. For every node, the height difference between its left and right subtrees can be at most 1. So meaning na dyan usa kani. So kaning usa daw nga difference is called the balance factor. Red block trees. The red block trees are another type of balanced binary search tree. They maintain a balance by coloring the nodes either red or black and applying specific rules during insertion and deletion. Red block trees guarantee a maximum height of 2 to the power of log n plus 1, where n is the number of nodes. More siya og AVL tree but different strategy. So each node is colored red and black. So every node, so the root is always black. So mo dyan ni ang red black trees. Kailangan ang root daw kuno is always black. All leaves are black. So ang leaf are black lang. Red nodes cannot have red children. So red nodes daw kuno that cannot have red children. So kani na red meaning incorrect. So kani na black correct. Black red. So kailangan ang iyang kuanan is black red or red black red ana. Then B3. B3 is a self-balancing tree designed to handle large amount of data efficiently. They are commonly used in databases and file systems. V-trees have a variable number of children per node, allowing them to store a large number of keys in a single node. So, ang B-tree, ang kalahiran niya is naatiyay daghan nga variable number. So, mausa siya. Instead of 2 children per node, B-tree nodes have many children. Like na as a picture. So we have 1, 2, 3, 6, 7, 9, 11, 12, 15, 17, 22, 36. Then lastly, we have trie. A trie, also known as a prefix tree, is a specialized tree data structure used for efficient retrieval of strings. It is commonly used in applications like autocomplete and spell checking. Each node in a trie represents a character and path from a root to the leaf nodes. Nodes form complete words. For example, we have this, we have and, aunt, dad, and do. So nga rin, naman tayo daw ka first letter, A and D. So, ang root node, here is for ang A, then ang D. Then after that, ang N, so it is N and N, ang like similar, and N, so N, sunod, and you have this T and D and T. So, yan na E, D, and T. Ano yan ang niya. First is a similar anay. So, we have D, then D, then A and O, A na O, then ang pinaka-last is D. So, this is used for, instead of storing entire string in nodes, each node represents a single character. So, tagsa-tagsa character. And paths from the nodes to the leaf spell out words. Ana. So each node can have up to 26 children for lowercase English alphabet. So next is we're going to discuss about tree representation. Nailahi-lahi of ways how to represent a tree or kanang dito nato. We have the array representation. In the array representation of a tree, the nodes are stored in an array. So the relationship between parent and child nodes can be determined using the indices. So an indices is this, kaning gray ones. Here, gray ones. For a node at index I, its left child is at index 2 to the power of I plus 1, and its right child is at index 2 to the power of I plus 2. So meaning, ang sunod-sunod na sila. For example, index 0, we have 1. Index 1, sa I plus 1, meaning 2. Then, plus, 2 na po, index 2, we have 3. Ano ba? Sunod-sunod. So, we have level of order 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, and 15. So, kailangan ana-ana siya. Then, next, we have the linked list representation. In the linked list representation of a tree, each node contains a pointer to its first child. The siblings are linked together using a linked list. This representation allows for dynamic tree structure, like this, connected. Pointer, chung, chung, left child, right child. Then we have left child, right child, left child, right child. Muna siya, linked list. Then, parent pointer representation. In the parent pointer representation, each node contains a pointer representation that simplifies certain operations, such as finding the parents or siblings of a given node. So instead of the arrow pointing down, here's the parent pointer. Ila i-point ang parent nila. For example, here ito ang unang child, parent, child na sad na parent. Yung child na sad na yung parent, ana. So this is the root node. Then ang parent kanay child, then ang parent kanay child, ana. So yeah, i-point ang parents instead na i-point pa down. Then we have child siblings representation. Left child, right sibling. So the child sibling representation, each node contains a pointer to its leftmost child and a pointer to its right sibling. This representation is particularly useful for trees where each node can have an arbitrary number of children. So, here ko no, a child na sad, child na sad. Then, a child na sibling, sibling. So, this can be used where each node can have arbitrary number of children. So that's all for the subject. What is tree and types of trees and tree representation?